All right. So homework for today was to um, generate a random number of exits, kind of as a starting point. So we're modifying our dungeon room to randomly generate a number of available exits between 1 and 4. Only allow your player to move toward an exit that really exists. For non-exits, do something visually to make the exits non-available. All right, so this is a visual experience that we're doing here, not necessarily something that we're going to code behind, but that's what we're doing next, where we're going to have a kind of a collection of rooms in our singleton that keeps track about the information of the rooms that currently exists. But let's kind of get the mechanics of a room having exits or not having exits. Okay, so one thing we could do is I'm gonna come here into our dungeon room, and we're gonna go ahead and bring in, is this the maybe prefabs? How about walls? I don't like any of those guys. Doorways? Is this a closed doorway? That's an open doorway. These are closed doorways. What is this guy? That's a gate. Well, I guess we could just have gates. So, full. Yeah, let's go with that. All right. So maybe we go ahead and we decide that um, certain rooms have, well, certain exits that get closed off. Maybe look something like, let's move that in something like that, where it's not an open archway. All right. So that's listed as a gated door. You can decide if you want yours to um, work differently. All right, so let's give myself, so that's under exits. So let's see. Okay, so let me do another empty game object. We'll call this one closed doors. And we'll move our doors under here. So we'll call this west closed. We'll go ahead and copy that guy. So look. All right, we'll call him east closed. Copy that guy. Drag him out here, rotate him some. Just start the rotation, and that should tell me what I need to update here. So I'll take it to 90. Drag that guy up there. Something like that. So that'll be north closed. And finally, a south closed. That guy. I didn't grab my mouse. All right, that side looks good enough. All right, so that is south closed. All right, you can position those things to look a little cleaner if you want. Now, one thing I'm going to do right off the bat is for all of those exits, I'm going to go ahead and put a box collider on them. And that should make us not able to move over those guys. Let me just test that real quick. So I'll try to head this to, does my guy not have a collider on him? Chomp has a collider, does he not? He has a sphere collider. Oh, he's a trigger as well. So if I turn his triggerness off, oh, he had a rough time there. All right, probably don't want him slamming against the wall. So let's set him back as a trigger and we'll uh, probably have to set all these guys up as triggers. And then let's give them a tag. So we'll go ahead and add a new tag and let's call this guy a closed door. So we'll highlight all those. We'll make sure we tag it a closed door. So we can't go in that direction. At this point, we're just trying to get the mechanics of a closed door to work. Just so we can't technically go through a door. We're going to make it so that we actually can't even try to go in that direction. So we may not even need to use these tags. All right, but we do want to have the ability to turn those guys on and off. So that means we need to make those guys available to some script that's controlling the current nature of the room. So last time we introduced this guy called a dungeon controller. All right, we have a dungeon controller script for this guy. So the dungeon controller, this guy, when it first launches, maybe his idea would be that he controls what exits are available, what exits are not available in the dungeon. Okay, so let's go over to our dungeon controller. So it's all right, so we're going to give ourselves a couple of, we're going to say public game object. Let's call this guy north, closed door, south, closed door, east, closed door, west, closed door. All right, we'll save that. And now when I click on our dungeon controller, we see that it's expecting 4 things to go in. So we'll drag our north closed door over here. We'll drag our south closed door over. Oop. Our east closed door. And our west closed door. All right, so now we have those guys programmatically available. Let's go ahead and remind ourselves Unity random number using random.range. Did we have to so this is inclusive. So we want to generate a random number between 1 and 4, including 4. So we would use something like this. So if we just want to test this real quick, I'll just say for a die is equal to 0, I is less than 10, I plus plus, and let's go ahead and print random range, and we're going to say 1 to 4. And let's see, so there's another version of this. Is there one that takes integers? Well, let's just see what it gives us between 1 and 4, because we really want random integers here. So I went ahead and just had my start function in that print out some random numbers. Yeah, so it gives us like 1 point something, blah, blah, blah. All right, so we want to get that to be an integer. So a version of random that gives us that range. Okay, so it looks like there's a version of that that takes just ints. So if I don't pass it floats, although that at a glance there, I think it indicated that the 4 would not be inclusive in this case, but let's find out. Save this guy. Why isn't it saving? Player that's not saved. All right, so let's go here. So there's a 1, 2, 3. I don't see any 4s in there. So it looks like it's non-inclusive, but we'll run it a couple more times just to make sure I didn't just not get lucky and didn't run a 4. There's a 4, there's a 4. Okay. So now we have the ability to generate a random number. So just to introduce a concept here, we've talked about it before. So there's 2 versions of random range, one that takes in 2 integers and one that takes in 2 floats. The one that takes in 2 floats, weirdly enough, includes the second value, but the one that takes in 2 integers does not include the second value. So this will give me a value in the range of 1 to 4. All right. Now, a couple of things that we could do here to accomplish this. So I mentioned that every room should have at least one exit that is, I guess, one exit that is available. Okay. And because we can't have a room with no exits. So for starters, we're going to need to make it so that we can code one exit that actually has, that's definitely going to be our open door. All right. So what we might want to do here is we might want to go ahead and get we'll say, open door. And I'm going to start that off looking like that. Okay, now I'm going to change our, well, let's see. Yeah, I'll go ahead and show this to you. So I have north, south, east, and west. So I'm going to update this, call this guy closed doors. And he's actually going to be a array of game objects. want you to see what this looks like. All right, I'll get rid of my print here for a second. Actually, I'm not going to even need this for loop, so let's get rid of that. All right, so I made my public variable here a variable that is a array. So this is an array of game objects called closed doors. Now, when I go back over to Unity and I click on my dungeon controller, notice here that I have an array that currently shows 0, but if I change it to 4, now it's expecting 4 things. So this allows me to load things into an array. Now I am going to have to remember that element 0 is one door, element 1 is another. So I'm going to go north, south, east, west. So bucket 0 of my array will be north. Bucket 1 of my array will be south. Bucket 2 of my array will be east. And bucket 3 of my array will be west. All right. Now you could have done it this way, or you could have created an array and loaded your 4 things in over on the code side. But effectively what I have now is I have made available to the code an array of 4 closed doors. All right. So now what I can do is I can go ahead and open, just let's say visually for starters, open one of the doors. So I'll say this dot close doors at bucket random range 1 to 4. So that'll give me actually random range 0 to 4. So this will give me a value between 0 and 3, which matches up to the indexes of my array here. Okay, so random range on this guy comes out to, I think that's okay. And we're going to say set active to false. All right, so when this dungeon controller first launches, what I'm going to do is I'm going to generate a random number between 0 and 3. I'm going to access that game object from my array of closed doors, and I'm going to set it active to false. That should make our one of our 4 closed doors disappear, showing an open door there. Okay, so we're just kind of testing this one little step at a time. All right, so I'll go ahead and run this, and now one of our doors should be open. All right, so we got an east door that was open. I'll go ahead and run it again. Still an east door. Run it again. We got a north door. Okay. So this first code guarantees that we have at least one open door. All right. Now, I'm going to go ahead and say int open door index is equal to this guy. So I'm going to remember my random number. Then I'll go ahead and set active whatever thing I open there. And the reason I'm doing that is my open door index is going to be equal to the index of the door that I want to guarantee is open. Then I'll actually make it visually open, but somewhere I need to set the fact that that door is open. All right, at least I might need that value for when we start linking this up to our room objects. All right, because now I know that open door index is the index of the door that is currently open. We may choose to use the new number. We may choose to ask whether something is active when our guy tries to go in a certain direction. All right, so let's just start with this and put in our logic for whether or not our doors are open. All right, so what I want to do here is inside of our dungeon controller, we're already creating an instance of a room. Now, a room has 4 exits in it, 4 doors. All right. So now what I want to do is I want to find out if these, which of these doors should be open. So for right now, I'm going to go into room. And right now we're keeping track of a single, um, uh, I don't know, a single exit or a single name rather. I'm going to go ahead and just add one thing here. So I'm going to add private string open door direction, since right now we're only dealing with a single open door. And then we're going to go ahead and say public void set open door. And we'll take in a direction. And we'll set this dot open door direction equal to the direction that was passed in. All right, so we've taught a room a little bit more information. At this point, we're only making it so that every room has exactly one open exit, but that exit is going to be in a random direction. All right, so after we generate that, we can go ahead and set the open door equal to a direction, north, south, east, or west. Okay. We can decide right now we're actually holding on to our variables in a bunch of different ways. So we're saying that we're keeping track of a number between 0 and 3. We might want to set an exit here to be a north, south, east, or west. So we need to have some way of mapping between 0, 1, 2, and 3 and the direction. So what we can do is we can go back over to our dungeon controller. And one thing we're going to want to do here is after we visually open a door, we want to be able to say r dot set open door, and we're expected to give this guy a direction. All right. But right now, what I have is a number, like a 2, a 3, a 4, something like that. So what I'll do is I'm going to create a private string map index to string for exit. And this guy will take in an int index. And we're just going to ask some questions. So we're kind of drilling our logic and stuff in here. There's a bunch of different ways we could have accomplished this. So we're going to say if index is equal to 0, we will return north. Else, if it's 1, we'll return south. Else, if it's 2, we'll return east. Else, if it's 3, we'll return west. And then we'll put an else on the end, even though we know we'll never get here. And we will return a question mark. All right. Now we happen to know that we're going to be calling map index to string for exit with some value between 0 and 3. So we're going to set this open door to this dot map open door index. All right, so we're going to let our instance of room that's associated with this particular dungeon room, with this particular dungeon controller, we're going to set his open door to whatever our map index to string for exit returns when we pass it that number between 0 and 3. So if we pass it a 0, it's good. This guy will boil down to north. So we'll set the open door's direction to north, so on and so forth. All right. Now, we need to keep track of this current room. Why is that? Somewhere in here, we need to have the ability, I said that if for instance, if it's the north exit that's open and our player tries to go west, they should not be able to move in that direction. okay, because that's not an open door. Right now, our code would let them move in any of those directions. So let's go look at that. Oh, I didn't save my room. All right. All right, so right now I have my open door to the west. I'm going to try to go east. And it worked just fine. All right. But do notice that we did get a new random open door here. But for instance, right now I should only be able to go south, yet I can go to the north if I want. We don't want to allow that. All right. So we need to have a way for the player, when we press one of our arrows, to check, is the way I'm trying to go a direction that is where an open door is? All right. Who knows about the open door right now? Well, the room object knows about the open door. Who has that room object right now? Well, our dungeon controller has that room object. Now, who is responding to the arrow keys being pressed up, down, left, right, whatever? That is our player controller that's attached to Chomp. All right. So Chomp's player controller will notice that we hit up, down, left, right. And we only want him to be able to go in a direction towards an open door. And right now, the only person who knows about the open door is our dungeon controller. And actually, even more problematic, we look at our dungeon controller, room is actually a local variable to start. So inside of start, we have set our room. All right. So I have two different game objects that really need some access to that room object. So our dungeon controller probably needs to know about the current room, and our player needs to know about the current room so we can determine whether or not we can go in certain directions. So what we're going to do is we're going to add our room to our singleton. All right. So right now I already put in there for a collection of rooms. We're not going to use that quite yet. Because we're trying to get the mechanics working for a single room. So we're going to go ahead and we're going to say public static room, call it the current room. And we'll start this guy off at null, even though we know we'll be setting it to something. All right, so now our singleton knows how to remember a current room. So we'll go into our dungeon controller. And now, rather than saying room R is equal to a new room, we'll say my singleton dot the current room is equal to the new room. So whenever we would have, and I am already adding it to my add room thing, we're not using this guy quite yet. So, you know, we can comment it out if we want, or just ignore it, just kind of make a note. Here, I'll say not using this yet. That's going to kind of come in our next assignment. All right, then we're generating what door should be open. Right now, we're only allowing there to be a single open door. We are then visually, so this will visually make an open door. That has nothing to do with logic. Okay, that's just visual. Then we're going to let our current room, which is controlled by our singleton, know that that's the open door, the direction we're going. All right. Now, inside of our player controller, we can now ask, is a certain direction allowed? So let's go ahead and inside a room, give ourselves a function. Public bool is open door, string direction. And we're going to return open door direction dot equals direction. So we've now added an ability to our room. So all rooms now know how to, if I call is open door and I pass it a direction, for instance, north, it will return whether or not the single open door direction is equivalent to the direction I passed in. If it's true, that means the door in that direction is open. If it's false, a door in that direction is not open. All right, so we put that logic for that inside of our door, or of our room rather. So now over in player, inside of update, when we hit our arrows, okay, so if we put the up arrow in, we want to only get into this code if there is a exit in that direction. So we're going to go ahead and put an additional and in here. My singleton dot the current room dot is open door, and this would be to the north. So if I press the up arrow, I'm only going to allow myself to go there if there is a door to the north that is open. Similarly, this will be to the south. Similarly, this will be to the west is the left arrow. Similarly, this will be to the east for the right arrow. So we only get into these if statements if the current room we're in has an open door in the direction we're trying to go to. Okay. So we'll go ahead and save this. All right, so now I see my open doors to the south. I'm going to try to go west, pressing the left arrow, not allowing me to do it. Try to go east, pressing the east arrow, the right arrow, north, up arrow, south, down arrow. All right. All right. Now, right now, we only have one exit that's toggling between the rooms, so it seems to be working okay. Now, again, keep in mind there isn't necessarily a single correct way of doing this. In fact, I might even argue that the way we're currently doing this is probably not necessarily great programming practice. But the reason I'm doing it this way is it really is drilling that idea of different objects knowing about different things and how do we share information between them and how do we write logic that, goes, can I go to the north? Can I go to the east? Things like that. So we're being a little bit, I don't know, hyperbolic, I guess, but it works and it's giving us some logic practice. So we're going to stick with this. But if you've done it somewhat differently, that's totally fine. There's probably 500 different ways we could argue, and a whole bunch of them maybe would make more sense than this. All right. Well, this only gives us a single exit in each room. Now, for the assignment, we were supposed to have up to 4 available exits, but not only 1. Okay. Or I'm sorry, but not 0. We can't have a room with no exits. Otherwise we have problems. All right. So the way we are now, I'm going to actually add to this a little bit, because one thing we need to consider here, do I want to do that right now? Let's keep it separate for right now so I can focus on what we're paying attention to. So it's our dungeon controller that is making the decision of whether or not the room we're currently in what exits are available in the room that we're currently in. And at this point, I'm only generating a single random door. All right, so now what I want to do is I want to find out how many additional exits should be available. All right. Now we could just roll the dice 3 more times. So for example, I know that a door in the direction of open door index is currently uh, open. So what I need to do is I need to determine all of the other doors other than that guy. So I know that current I is equal to 0. I is less than 4. I plus plus. So I know I have 4 total exits. Now, which exit is currently open? Well, that value is stored inside of open door index. So I can ask the question, if open door index is not equal to I, or I not equal to open door index, they mean the same thing. So this says if I am not looking at the already open door, then we're going to say, should this door be open or not? All right. So what we might do here is you might say, well, why don't we just flip a coin? All right. So we might say int coin flip is equal to random.range. And we're going to pass this guy a 0 to 2. So that'll give us a random number between 0 and 1. If coin flip is equal to 1, open the door in that direction. All right. So what we're doing here is I know I'm going to have up to 4 total doors open. Again, there's lots of different ways you might accomplish this. I'm doing it in ways that really drill our logic testing. So I'm saying I'm going to open up to 4 doors. I know I've already opened one of those doors. So if this particular time through the loop, I'm considering the door that's already open, just don't do anything. So I'm only going to consider doors that are not already open. So if I'm looking at a door that's currently not open, I'll go ahead and flip a coin and get either a 0 or a 1. If I got a 1, we're going to go ahead and open that door. So initially, let's just visually open the door. So I'll go ahead and say, actually, I'm not, this is the visual one, sorry. So I'll go to my array of closed doors. Instead of open door index, I'm going to go to door I. All right, because that's the door we've currently determined, for the 4 doors. Door I is the one I'm currently looking at. We know I is not the original open door. I'm going to say door I want to set U active to false. So this turns off the closed door. All right. So we'll do that 4 times, but we'll only actually apply the logic 3 times since one of our doors is already open. All right, so did we really literally get 0 additional open doors? That seems very unlikely. Oh, we literally did get 0 open doors. Okay. So this case, we had 3 open doors. Still have 3 open doors. Okay. Now it's only actually letting me go towards the original door that was open. So we can determine which door was all of them are open this time. So without knowing which door was the one door that's actually open, my current logic, I'm trying to go west right now. So even though we visually see an open door, that wasn't one of our original open doors. All right, so now we need to enhance our room to allow us to know whether or not additional doors were open. So right now, we only keep track in a room of open door direction. All right. And we set an open door based on that direction. So what we need to do is we need to keep an array of strings, up to 4 of them. We're going to go ahead and say we're going to have a private string array called the open doors. And this guy will be a string array that can hold up to 4 things. Then we're going to have a private int, how many open doors, and that guy will start off at 0. So when we set an open door, passing it a direction, we want to update our open doors. This dot the open doors at bucket, how many open doors is equal to direction. So if we just open north, we'll set bucket 0 to north. Then we need to say how many open doors plus plus. And as usual, I like to put this in front of these things. All right, so when an external entity says, I want to set one of your doors to be open, here's the direction you should open. This guy will add to his array of strings that direction that's being opened. And then he'll increase the number of open doors that there are. So we make sure we place the next one in the correct place. Now, keep in mind here, so again, we're kind of talking about good programming practice. Keep in mind that the current setup here relies on us as the programmer making our various scripts talk to each other in a way that they kind of have to know how each other works. You know, that is, if I generated a random number 3 in one script, I have to know that that gets mapped to west so that I know I can call this guy passing it a west. Similarly, I'm also relying on not setting open door to north 3 times. So we have kind of points of failure here, but as long as we're the ones writing it, we can control it. You know, you can sit there as a programmer and say, well, how do I make this kind of idiot proof where, you know, you can't really break it? We can spend time, I'm sure, come up with a way for that, but this gives us a lot of practice doing this stuff. All right. So we'll set the open doors. Now, in is door open, rather than just checking against a single thing, we want to check against all of our possible open doors. So this dot, how many, oy, oy, oy. How many open doors? I plus plus. So we're going to loop through, and this is I is less than that. So we want to loop through our array of the open doors, and we want to see, are any of those doors equal to the direction? So we'll ask the question, if the direction you're looking for dot equals this dot, the open doors at bucket I, then we will return true. All right, so as I go through my open doors, if the door I'm looking at is an open door and it's the door you were interested in, I'll return true that yes, that door is open, you're allowed to move in that direction. If I'm still alive here, I'll return false. That is, whatever direction you wanted to go does not have an open door. We didn't find it in our array anywhere. Okay, so we've upgraded our logic here. to now work on all open doors. Okay, but this is now reliant on us making sure that whenever we find an open door, we set the open door. We haven't done that yet. So now we're going to go back into our dungeon controller. And here's where we visually set the door on or off. So now what we want to do is we want to do the logic side of this, where we'll set our current room, we'll set an open door, we're going to map the index to the string for that exit, and the door we're working with here is door I. All right, so I will let my room know that there is an additional open door in the direction that map index to string for exit gives us. So that's this guy right here. So a 0 becomes a north, a 1 becomes a south, 2 becomes east, so on and so forth. All right, so here we're going through and we're opening up additional doors, up to 3 additional doors. This visually makes it open, this logically makes it open, such that when I come into my player controller and we try to go in a certain direction, hitting our arrows, we ask, is the door to that direction open? Now, since our logic is making that work on a collection of potential directions, because a room has potentially many open doors, up to 4 maximum, but we keep track of how many actually got added. We now should be able to create an environment where we're in a room. This guy has 2 open doors. I'll go. So I must not have saved something. Dungeon controller, not saved. So I can go east. I'm not sure which of these doors was the one that was already open, so we'll just kind of test enough to, try to convince ourselves that this is working. Seems to be. Okay. So we have that guy working. So I'll push that code. Now for our homework, starting with that sample code again. And what we want to do we want to keep track of the existing rooms that have been built and make sure that if a player exits in a particular direction, the next room allows them to go back. To the previous room. This means that rooms should only be randomly generated the first time and should be loaded from our array of rooms in the singleton otherwise. So an example, if I am in the randomly generated starting room and head west, the next randomly generated room should guarantee that there is an exit back to the east that takes us back to the original room that is not randomly generated again. All right, so we're trying to make sure that the first time we come into a room, it is randomly generated, but we also want to ensure that we have an exit back to where we came from. All right. So for right now, we're going to say this only has to work for 2 rooms currently. So it's a starting point for our whole dungeon. All right. So you don't need to worry about storing a whole collection of rooms that know about each other. We're going to get there, but we're going to have to introduce a data structure to do that. All right. Questions, comments, concerns, bribes?
Actually, Professor, I got something. Can I talk to you after the class once the Zoom clears up a bit?
Yep. No worries.
Sweet, sweet.
All right. Anything else? All right. I'll push my updated code and I will see everybody on Monday. I am planning on being back in person on Monday. All right. Take care.